Welcome, algebra students, to the beginning of Chapter 5, Lesson 1. So Lesson 5.1, beginning on page 105, Simplifying Simple Algebraic Fractions. Just a quick review of all of the steps for fractions. First of all, algebraic fractions work as numerical fractions. So when we add or subtract an algebraic fraction, we also need common denominators. When we multiply an algebraic fraction, we multiply the numerators and multiply the denominators and then put them in simplest form. Just as we divide fractions, we would do the same with algebraic fractions, where you keep the first fraction and then you multiply by the inverse of the second fraction and then proceed as if you're multiplying. The second rule for algebraic fractions is denominators cannot be zero. If you work out a problem and you find out you have 0 in the denominator, you did something wrong and you need to go back and figure out a different way of simplification. Simply, if your denominator is 0, that means you have so many parts of nothing, which is impossible. The next thing to remember kind of goes with having equivalent fractions, making equivalent fractions. So think of that as you read through this and write it down. Value of algebraic fraction does not change when both its numerator and denominator are multiplied or divided by the same non-zero number or expression. So if you are multiplying or dividing by the same non-zero number or expression, you're basically multiplying or dividing by 1. And so you don't really change the ultimate value of that fraction. You just simplify it or increase it. Finally, algebraic fractions need to be in simplest form through factorization. So knowing all of that, we're going to proceed now to try it. Number 1 at the top of page 106. So the problem is 28x to the third y to the second over 20x to the second y to the fifth. Our constants, 28 and 20, need to be reduced. So you decide what the greatest common factor is of the constants. In this case, it would be 4. Then you take a look at the variables, which in this case are the x's and then the y's. First, the x's. You take your lowest power. In this case, it's x to the second. In the y's case, it's y to the second. And that's putting them all together. You will have your reduction expression. So if I take this fraction and out of each one I take 4, which is my greatest common factor, x to the second, y to the second, I find out what I'm left with. Well, 28 divided by 4 is 7. X to the third, if I take x to the second out of there, I'm left with just plain x because I subtract my exponents. If I take y to the second out of y to the second, it disappears. So I'm left with 7x on the top. Doing it the same way on the bottom, 20 divided by 4 leaves me with 5. X to the seconds disappear. Y to the second, taking it out of y to the fifth, leaves me with y to the third because I simply subtract my exponents. 5 minus 2 is 3. So this goes away because that's just 1, and I'm left with that. My solution is 7x over 5y to the third. And that's my answer. Continuing on to example number 2. This gets a little more complicated, requires sometimes a little bit more. Oops, not example number 2 yet. We're going to do letter B. Forgot about letter B. So sorry. Anyway, going back to try it 1, letter B. Here we have 25mn over 5m to the second plus 15mn. So now I'd have to decide the greatest common factor for all 3 of those values. So between 5, 25, and 15, my greatest common factor is going to be 5. Again, the common variables, I have 3 m's now, so I can take out m, just plain m. M to the second is the highest. I just have singles here, so I can take out an m. There are not 3 n's. That only appears in 2 of the values, so I cannot take n out of anything because I would have to have it in all 3 in order to take it out. So I'm going to have this fraction, I'm going to divide by 5m. Doing that, 25 divided by 5 leaves me with 5. The m's disappear, and I'm left with n. 5 divided by 5 is 5m out of this expression. So first of all, 5 divided by 5 leaves me with nothing. M to the second, if I take an m out of that, I'm just left with an m. Plus, 5 out of 15 is 3. My m's disappear, and I'm left with n. Okay, did you see how that worked? So basically, with this part, I'm dividing this one, that 5m to the seconds, because 5 divided by 5 is 1, so I don't need it. M to the second divided by m, which is like m to the first. I subtract my exponents, I'm just left with m. So that's that part. Now, taking 5 out of a positive 15 leaves me with a positive 3. I take m out of that expression, so they disappear because it's gone, because m to the first minus m to the first is m to the 0. And then I'm left with n. Now I can cancel out my 5m's, and I'm left with 5n over m plus 3n. And that's my answer to that one. Now we can go on to try it 2. Try it 2. I'll move this up here so I'm in a little better light. It's kind of dim in here tonight for some reason. So problem A in try it 2 is 3px plus 15py minus 2qx minus 10qy over 21px minus 3py minus 14qx plus 2qy. I am going to factorize by grouping terms. So I'm going to group these xy's because they have a p connected to it, and these xy's because they have q connected to it. Also, these are all even numbers, and these are all factors of 3. So in that first set, I can take a 3p out of this value and a 3p out of that value. So I'm going to do that. So if I take 3p out of this first value, I'm left with, 3p in here goes away, so I'm left with x. If I take 3p out of positive 15py, I'm left with 5y, positive 5y. Underneath, I'll take 3p out also, and that leaves me with 7x minus y. Okay? Because 3p out of a negative 3p is just a negative 1, which I don't need, but I keep. And then there are no y's, so I'm left with that. Now over here, I'm going to take out a minus 2q. So if I take it out of this first one, a minus 2q out of that, I'm left with x. If I take a minus 2q out of a minus 10, it's like minus 10 divided by a minus q, I'm left with a positive 5y. Okay? Then I'm going to take a negative 2q out of the bottom two values. So 14 divided by negative 14 divided by negative 2 is positive 7. The q's disappear. I'm left with x. A positive 2q divided by a negative 2q is like a negative 1, so I need my negative sign because I'm only left with the y as the q's go away. Okay. Now, what I need to do on the top and the bottom, notice I have x plus 5y in both cases in the numerator and 7x minus y in both cases in the denominator. I'm also left with 3p minus 2q in the numerator and the denominator. So I'm going to group these two together, 3p minus 2q, and I only need one of these times x plus 5y. again, 3p minus 2q times the 7x minus y. These eliminate and go away, and I'm left with x plus 5y over 7x minus y. That sounds a little complicated, but if you just keep this in mind, and then this in mind, as you factor things out, if I take the 3p out of here, the 3p eliminates, I'm left with x plus 5y. Same thing here, I'm left with 7x minus y, and so on and so forth. Okay, if you don't understand that, please ask or rewatch again. Just a quick explanation. If I take a negative 2x out of this, a negative 2q, excuse me, out of this, I'm left with just x. If I take a negative 2 out of a negative 10q, I'm left with a positive 5q, because remember, when you multiply or divide by things of either negatives or positives, it's always going to be a positive number. Go back to your working with positive and negative sheet if you need to. So I'm left with 5y there. If I take a negative 2q out of a negative 14qx, I'm left with a positive 7x. And because I'm dividing by a positive by a negative, my answer is going to be a negative. It's a 1, which I don't have to write. The 2q's go away and I'm left with y. Now in this case, you want to have the same thing here, the same thing here, and the same thing both here and here, because then you can regroup it this way into this value times that value, and this value times that value, which gives you the final answer. Okay, so that's A. Let's go on to B, where we have 3x squared minus 10x minus 8. Notice the form of the numerator. Ax squared minus bx minus c. So it's like the last unit. So what we need to do with the numerator is do the cross factorization. So I put it into the form, it ends up being 2 times negative 4 is the negative 8. 2x plus negative 12x equals negative 10 when I do the crosses, negative 10x. So my factorization results is 3x plus 2 times x minus 4. So that's my numerator. Now I got to look at the denominator. This will follow the special form. Remember those special forms that we did, the special rules? So this is going to follow something squared minus something squared. So I'm going to use the square root of 16, which is 4, to get it into that form. So I have 4 squared minus x squared. So in that form, I know I can zip down to 4 minus x times 4 plus x. That's my denominator. Now I put my numerator over my denominator. Noticing right here, these two are going to cancel out. The x minus 4s are going to go away. They just kind of eliminate. So I'm left with, okay, I already showed you that. Oh, not yet. X minus 4, and this is 4 minus x. That's a problem. That's a problem because you want it flipped. So the solution to that problem is this, where you're going to multiply this value by a negative 1 so you can flip the sign. So you're going to have a negative 1 times this. So yeah, I jumped the gun here. So now I have x minus 4 and then a negative, there's like a 1 in front of here, times x minus 4. Now I can eliminate my x minus 4s. Leaves me 3x plus 2, but now on the bottom it's going to be a negative 1 times that. So that just kind of makes the whole thing negative with 4 plus x. Since if the whole thing is negative and this is a 4 plus x, to get it in the right form, I can just flip them because they're both positive, because the whole thing is negative. So I just flip them, x plus 4. So my answer is a negative 3x plus 2 over x plus 4. That kind of went away there. Okay, lots of stuff going on here. Lots of, you didn't even see that bottom part. Sorry. But basically I just repeated this down here. I think that's the part you didn't see. The tricky part is once it gets to this form, I want to eliminate something. These are the two closest ones I can eliminate. In order to flip the signs, I need to make this negative to get the flip. At that point, I can get rid of these, but I'm left with that -1. Basically, that just makes the whole problem negative. So I just copy it down, and then I put these in the right order over here, and that's how I get my answer. Okay, lots going on here, especially in example 2. This is where all of what we've learned to date comes into playing, especially with cross multiplication and those special forms that I asked you to repeat or copy down somewhere handy so that you recognize perfect squares, because that just makes going from this to this really simple, and you don't have to do a lot of factoring out. So keeping all of those rules in mind, your assignment for tomorrow is page 107. Do all of number 1 and do number 2, A, B, and C, and stop there. That will give you plenty to chew on. Please ask questions if you run into a stumbling block, and do good math. Remember, you can always rewatch this. You can always ask questions. This is a lot of stuff going on, so the slower you work, the more methodically you think, the more things you write down on your paper, the easier it will be. I'll be looking for things. Notice it took me a whole piece of paper to do one problem. There's just that much thinking. Keep that in mind. And now, do good math. Page 107, all of number 1, number 2, letters A, B, and C. Thank you.